Hi everyone, very good morning to you and welcome to the Big Data Info Session by Saurabh Mukherjee. So today, as you all know, you are all a part of the applicant pool for the postgraduate program in Big Data Engineering by BITS Pilani and Upgrad. Today's info session is exclusively for each and every one of you to get a better idea of how big data is really applied in business scenarios and what sort of big data careers can you be a part of. How can you maximize your career in big data? Today, we have with us, we are very, very fortunate to have with us Saurabh Mukherjee, who is the Vice President of Accenture Innovation Center for Data. He has 20 years of experience in data management, big data, and data analytics. He has been a wonderful source of support for this program since he has guided us and let us know what really is relevant for the industry, what are the skills that the industry is looking for. Today, he has very graciously accepted to interact with all of you to tell you a bit more about big data, its applications in the industry, and what sort of careers you can be a part of. A quick introduction to myself. I am Radhika Maloo, Senior Program Manager for the BITS Pilani and Upgrad postgraduate program in Big Data Engineering. I will be conducting today's section and I will be introducing Saurabh to you and will be ensuring that we follow the agenda and have enough time for question and answers from each one of you. Again, for the benefit of those who have just joined, big welcome to all of you. I'm Radhika Maloo, and now for the agenda for today's session, we will have Saurabh introducing himself. Then he will be speaking about the big data, what really is big data, what are big data applications in the industry, and how really you can create your career in big data. As a quick reminder to everyone, because you all already must be aware, Saurabh is the Vice President for Accenture Innovation Center for Data. Fantastic opportunity for all of you to ask whatever questions you have about big data and get expert advice today during this industry webinar. I'm going to share the screen to Saurabh now. Hello, Saurabh, and welcome.
Hey, hi Radhika, and good morning, everyone. Really excited to see all of your interest in these new and upcoming technologies, and very happy to be here. We'll go through a few slides just to give you a perspective of where the industry stands today. What are some of the applications of big data that we are looking at, and then I would be very happy to take whatever questions you might have about big data in general, about the program, and so on. So, yeah.
Great. So I'm going to thank you, Saurabh, for that. I'm just going to start the presentation where we
Sure.
can take that forward then.
Sure.
Thank you. So maybe I'll just give the quick agenda again for the benefit of those who have come in. We have Saurabh Mukherjee with us right now. He's going to be speaking about the change in the IT industry. Why is this happening? How can you protect yourself? He will talk to us about what really is big data and how big is big data. He's going to talk about the applicability of big data in our lives, the growth of this industry, salary growth in big data versus traditional IT, what job tracks in big data should you aim for depending upon your skills, upskilling in big data, what really does that mean? And then I will talk to you about this program, a brief introduction to our program. Over to you, Saurabh.
Yeah, thanks, Radhika. So this is the first slide, and I think it's a great one to start with because, as we all know, when we look around today, we watch the television or we read the newspaper. There are always, some of these extremely, confusing messages that are coming out in terms of how many jobs we are all set to lose. The industry is going through a crisis, and so on and so forth. Now, the first thing that I would like to mention is that I honestly do not see this as a very threatening situation for
Saurabh,
us.
your voice is getting a bit muffled.
Is it better now?
Yes, it's better now.
Yeah. So as I was saying that, as we look at some of these numbers that are being discussed, it's very easy to get threatened and feel extremely anxious about what's going on around us. But I really do not see this as a threat. I see this more as an opportunity. And let me take a couple of minutes to explain why. So the change that we are seeing today is nothing new. I think you know we always had this kind of a situation over the years, as technology has progressed, as new trends have come in. So if you really look at the age of industrialization, for example, obviously the discovery of a washing machine meant that a lot of the manual work for washing our clothes was taken away. I'm just giving a very crude example so that you can relate to what I'm going to say going ahead, right? So anytime you start automating things, anytime you start having intelligent machines do the work that human beings were doing so far, there is always this threat of a job loss. But the question is this really
Saurabh,
a threat?
Saurabh,
Yeah.
sorry, your voice is again getting.
Oh, is it? Is this slightly better now?
Yes, Saurabh, I think there's some internet connectivity issue because your voice keeps getting muffled.
Oh, okay.
Your voice is breaking.
Hmm. Okay, I think let's continue. Anytime
Sure.
you feel that I may need to repeat something, I would be very happy to do that. Yeah.
Absolutely. Thank you, Saurabh. Thank you.
Okay. So yeah. So the whole idea is that we should not look at this as a threat. The way we should look at this is more of an opportunity where there are new avenues and new opportunities which are really opening up for us. So if you look at some of these facts today, which says that about 70% of the jobs in India today are threatened, or it's even a higher number in China, 77 to 80%. It is mainly because a lot of these activities are now getting automated, and you have technologies like automation, machine learning, artificial intelligence. All of these are essentially coming into play. So let us not look at this as a situation of threat. The way we should look at this is that if today I have a set of skills, how can I upgrade my skills? How can I really cross train myself and become relevant for the new and emerging technological changes which are happening in the market and globally? This is not just about India. This applies to everybody in the industry today. So if you look at some of the messages on the right hand side of the graphic, essentially what we are saying is that a lot of these traditional low skill jobs such as manual testing are becoming automated, and hence these are becoming redundant. And it's not just about manual testing. I think it's about a lot of application development which we were doing so far, let's say through coding, or a lot of the work around maintenance of applications, around infrastructure management. So all of these are now being repositioned as jobs which would require new skills and enhanced skills. So that is essentially the message that we are looking at. And what are these new skills? The new skills are essentially around data science, which encompasses areas like big data engineering, analytics, and so on and so forth. And obviously, automation, machine learning, artificial intelligence. So the key message here is that let's not get very threatened by all the messages that we are seeing in the media. Let us take this as an opportunity to cross train or upskill ourselves and become relevant for the changes which are happening in the market. Yeah. So let's move on to the next slide, Radhika. Okay. So let's start from some of the very basics. So what exactly is big data? And I think that the normal tendency is to look at big data in terms of the size of the data. So obviously, if we look around today, there are huge volumes of data which are being generated from a variety of sources. And you have the number here, right? So 2.5 quintillion bytes of data are being created every day. And all of the data that we have in the world today, 90% of that data was actually created only in the last 2 years. And so this is an extremely important message that we are looking at. You can look at the graphic, and there are quite a few numbers that you see there in terms of what volume of data is being generated every 60 seconds. And just so that you have an idea, there are like 600 terabytes of data that Facebook deals with, right? And like there are 1 million users every month for Facebook and for Google just for the search function. So that's the volume of data that we are looking at. However, what I would also like to mention here is that big data is not just about the volume of data. A company could have a relatively lesser volume of data as compared to some of the numbers that you see here, and might still have a big data problem, because there are various other parameters by which you can classify data as big data. So size or volume is obviously one. The other thing is also the velocity, which means the speed at which data is coming to you, the speed at which data is being generated, and hence needs to be stored and processed and analyzed. So that is an extremely important factor for classifying data as big data, which is the velocity of the data. Then the third parameter is the variety of data. So without going into a lot of technical details, most of the data that we have been working on so far is called structured data. So this is data that you can put in a table, you can organize the data in rows and columns, the tables can be related to each other. So it's a very structured and organized way of data management, and that is something which we have been working on for several years now. However, if you look at various other forms of data which have become extremely relevant today, we look at what we call a semi-structured data. And semi-structured data is data which cannot be put or organized, let's say, in database tables, but it still has a semblance of structure or method in the whole data set. So for example, the data that you see in, let's say, an XML document, where there are tags that can be used to manage the data, or JSON data. So just some examples of semi structured data. And the other kind is the most the more, I mean, quote unquote, disorganized form of data, which we call unstructured data. So for example, the images which are captured in, let's say, CCTV cameras, right, or the videos that we upload on the social media, or the pictures that we receive from satellites, which are basically the weather satellites, for example. And as you understand, these are extremely important sources of information for various industry applications, and we will talk about some of the industry applications down the line. So these are extremely important sources of information that we deal with, but this data is completely unstructured. It cannot be put into a database table. It is not something which can be organized by tags and so on. So this is the other form of data. So any data which is in this format is also big data, and that is something to be understood. The fourth factor, and I think which uh, every organization is now realizing, is what we call veracity, and it is the fourth V. So we have three. We earlier used to talk about three V's, right? So volume, velocity, and variety. Now there is a fourth V, which is called veracity, and it is about how trustworthy is your data, because a lot of these big data applications depend on sources of data like social media, over which nobody has any control, right? Today you can go into Twitter and write anything that you feel like. Okay, so there are trolls who are posting a lot of unverified and unvalidated data which is not authentic. So and if we do an analysis of all of these data and try to derive some conclusions or insights from that, those conclusions or insights may not be accurate. So there is this whole question of trusting the data, and this is where the data veracity comes in, right? So these are essentially the different parameters by which you can classify data as big data, and it is extremely important to understand that, because then you will slowly realize the extent to which all of these information is being used by different industries, and why it is very important for you as a practitioner to be aware of these different forms of data, understand how you can manage and work with the data, and accordingly align yourself to the new and emerging programs which are coming up in the different companies. So Radhika, we can move on to the next slide.
Great. Thank you.
Yeah. Okay, so here are some very interesting numbers, and very encouraging numbers, in contrast with some of the bad news that we saw on the first slide. So there's a general estimate, based on the different job portals, the popular job portals, and professional social networks like LinkedIn. Approximately 15 to 20,000 big data jobs are available in India today, and if I look at the big data market as a whole, uh, as on date, which is 2017, this market is worth $2 billion. and in the next 8 years, which is by 2025, this is expected to grow up to 16 to 17 billion dollars. And India happens to be one of the top three destinations for big data job in the world. And I'll tell you why, because I often get this question as to why is big data uh, more important in India than anywhere else. And the answer is very simple. If you just think through this, and it's not just big data, it is basically, I mean, it's not just India, but it's basically a lot of these Asian markets where big data has suddenly become extremely important. And there are two or three primary reasons for that. Firstly, if you look at the way the industrialization has happened across the world, most of the manufacturing companies, right, some of these automobile manufacturers like Volkswagen, and some of these very large companies, Toyota for instance. So all of these companies have their manufacturing plants in the Asian market, mainly because of cost reasons. So they're here, labor costs are relatively cheaper, and over the years very large manufacturing plants have been set up in the Asian and the Southeast Asian markets. Now, what happens is, if I look at some of the industry applications of big data, and I will come to those down the line, big data has an extremely important use case in the manufacturing industry. So typically what used to happen, even till a few years back, is that you have a manufacturing plant, and there are heavy machines and the production lines which are being operated round the clock. Now, if there is a defect in a particular machine part, the machine goes down. And what that effectively means is your production stops for the day, or for more than one day, depending on how much time you actually need to fix the defect that has come up in the machine. Now, with big data, what's happening is that these machines now have sensors installed on them. And these sensors are continuously generating data about the health of the machine. And this is big data, because this is huge volume of data which is being generated real time, round the clock. uh, this is what we call as instrumentation data. This is the data that comes out from all of these machines. And you can analyze this data, and even before the machine actually goes down, you are able to figure out if there is a problem in any of the machine parts, and you can do a more proactive maintenance rather than a reactive fix of the defect in the machine. So this is a fantastic application of big data. And because there are very large number of manufacturing plants, production lines which are situated in India and some of the other Asian countries like Japan, for example, this is a big source of big data, and there's a big opportunity for big data projects in this part of the world. Secondly, as we all know, most of the call centers and BPOs are basically located in this part of the world. So, the largest of organizations in the world, the largest of service providers, airlines companies, all other kinds of service providers, retail companies, manufacturing companies, they have their call centers in India. I mean, over the last several years, India has been the destination of choice for a lot of these call center and BPO jobs. Now, uh, typically what happens in a call center? You are basically handling customers, right? So customers calling up the call centers round the clock for a variety of purposes. So there are a lot of business processes which are being conducted through call centers. Customers are also calling up call centers to register their complaints, to share feedback, and all of these are extremely important for a business. You need to have a very clear understanding of your customer, about the sentiments of your customer, and accordingly you design your products and services. And as you understand, as a customer calls up these companies, the voice data that we are looking at is essentially big data, right? And a lot of this data is basically recorded. Every time we call a call center, we get a notification right at the beginning that this conversation would be recorded for quality control purposes. So essentially, your interaction is getting recorded somewhere, and people are analyzing all of these voice calls. They're analyzing what the customers are saying about their products and services to take better business decisions and improve the quality of their products and services. So once again, huge source of big data in this part of the world, and extremely high opportunity for big data jobs and programs here. So this is not surprising. So this is the right time, and this is also the right place for us to acquire these kind of skills and make us relevant to the business. So I just wanted to give you a lay of the land in terms of what kind of opportunities we can really look at. And this is a topic that we will also discuss in more detail, as we go along. Yeah. So Radhika, next slide, please.
Yep.
Great. So, just in order to make this more real and give you a feel of what kind of industry applications we are looking at, uh, I wanted to talk about a few case studies here. So, Amazon, for example, if you look at the data that Amazon deals with, they're basically looking at a customer base of more than 150 million customers, and I think all of us in this discussion today are heavy Amazon users. Like pretty much everything that we need, we first go to Amazon and check out whatever discounts and offers we have there. And as we have all experienced, Amazon essentially makes recommendations, right? And so Amazon uses a technology that is called a recommendation engine, and what it essentially does is it looks at your purchase pattern, your behavior in Amazon, what kind of categories that you typically go into, what are the kind of things that you typically purchase, and it makes purchase recommendations based on that. So this is one of the key use cases for Amazon. Netflix, once again, or Amazon Prime for that matter, which is basically the audio and the video services that these companies provide. So here are some data for you to look at. There are 4 million ratings in Netflix, 3 million searches that people do on Netflix. And again, it is about the recommendation. So Netflix basically has two kinds of recommendation. On the one hand, it will make some recommendations for you based on whatever you have already watched, so it has an idea about what kind of things you want to watch, what are your preferences. And the second criteria for recommendations is what people are usually watching, what is most popular in Netflix at the moment. So for that, it is not only about you, but it is also going through its database of all users, all of the ratings which have come in for the different content that's there on Netflix, and it's making a recommendation based on that. And remember, all of this is basically happening in real time. So every time you are logging into Netflix, you are able to see what other people are watching. You are able to look at recommendations that Netflix makes based on your preferences. So there are multiple levels of recommendation that come in from these kind of websites. I will also add a few more here. So Uber, for example, I think all of us are Uber users today, and if you really look at it, Uber is essentially a technology company, and it's a kind of service that we call an aggregation service, right? So essentially, Uber doesn't own a single car. So Uber is not like your neighborhood car rental agency who basically has to maintain a fleet of cars, who has to pay the drivers to serve you. Uber does none of that. Uber is essentially a technology platform which is connecting users across the globe with independent car service providers. Uber doesn't own a single car. It's just a technology platform, just like Amazon, right? So Amazon is not really it's not a supplier or a retail platform in that sense. It's essentially an aggregation platform. So all of these at the end of the day are technology companies. And in order to add to this, I will talk of a very exciting program that I was personally a part of, and you would be able to relate to how big data is basically applied across industries. So this program was for a retail company, right? So we all understand. So I will not be able to share the exact details of the client. So this was a client in Europe, but think of somebody like Spencer's, for example, right? The departmental stores that you have now. This retail company had its outlets in different parts of the city, and then moving on at a larger scale to different parts of the country. Now, what the client told us is very simple. So he said that, look, I have my outlets in different parts of a city. I would like to understand the sales performance across all of these different outlets, and I want to be able to make predictions and projections about the sales that will happen from the different outlets across the city. Now, when we started the program, we realized that let's take a look at what are the kind of factors that would basically impact the sales of different products in the outlets of this particular company. The first thing, obviously, let's say, is weather. And I'll give you a few examples. There were a very large number of parameters. If I start talking about them, we will probably end up taking the entire time of the call. But just to give you an idea, I'll talk about 3 or 4 parameters, and it's really exciting, and you would be able to relate. So this the retail outlets sells different kinds of clothes and garments, and there is obviously an impact of weather on the sales of garments. So if it is the winter, then it would be selling more of woolen garments and sweatshirts and so on and so forth. The second important parameter that we looked at is, and this is very real time, and it could change from every week to another, uh, is whether there are events which are happening in that part of the city. So for example, you have an outlet near, let's say, a sports stadium, and there's a cricket match that's coming up, and so obviously it's expected that you would have uh, a lot of sales of, let's say, chips and snacks and soft drinks which people would buy from the outlet before they walk into the stadium, right? So important parameter is the events which are happening in the neighborhood. The third and very important criteria that we also looked at is the income, the per capita income of people who are staying in the neighborhood of that store, because that would also determine the kind of products that sell most from that particular store. So if it's a very affluent community, then a lot of lifestyle products would be sold, whereas if it is more of a middle class, lower middle class, then probably the larger sales would be more around your day-to-day commodities, the stationaries, and so on and so forth. So the income pattern of people living in around that store obviously has a significant impact on what's getting sold from the store and in what volumes. So one part of our job was to aggregate all of these information from different sources of data, right? So what we realized is that the weather data can be sourced from service providers like the weather company, or AccuWeather is an app that we all have on our phones. So weather data was one part of that. Then again, there are websites which basically publish event calendars for the entire year. So how you sort of aggregate that data to predict what kind of events are coming up in the next several months. And then in the countries where we worked in, the income information of the population is actually available from the annual census that takes place in all of these countries, and that data, and some of the data is basically made public, and you can actually purchase the data. So all of these are basically publicly available information which we aggregated in one place, and then we aggregated all of the sales data specific to that company in another data repository. And then when we sort of aggregated and uh, did correlated these different sets of data, we were able to come up with models. We were able to come up with models of customer behavior, of sales, and based on these models we could actually make predictions about how the sales performance would vary over the several months. So as you understand, this is something which is extremely important for a retail business today. They need to understand what is driving their business and how they can improve on that. In fact, just so that one of the outcomes of this project was also what are the different products that they should display in what manner in the different shelves within the store, right? So because during a particular month of the year, if there is a possibility of a certain type of products being sold more, they would be very prominently displayed inside the outlet. So the key thing is that for all of these different, and I just give you one example for a retail client, but the key issue is that processing of big data and coming to conclusions or business insights based on analysis of this data is extremely important. And as we go along, I would be happy to take questions around other applications that I can talk about. So Radhika, we can go to the next slide.
Yes.
So this is finally is something very exciting that you would all be very happy to look at. So see, again, these are not I do not want to generalize this because a lot of these will vary from company to company, but in general we are looking at a hike of, let's say, 30 to 60% in the big data industry today, obviously depending on the kind of role that you play here. And again, that's a very important discussion that we would come to a few slides down the line as to what are the kind of roles that we are looking at. But in general, there's a significant hike that we are seeing. So what we've done here is we've split up the entire population into different buckets based on the levels and the years of experience. And The yellow ones are basically the bars for big data. The ones in purple are basically the ones about the the traditional technologies that everybody is working on today. And depending on the value that you add, depending on the kind of work that you are doing, as you can see from the graphic, we are looking at a 30 to 60% hike, and this is based on analyst data as of October last year. So this is still extremely relevant. What we will do is, as we go along, we will talk about what are the different roles that you can play depending on at what level of experience you are in at the moment. Yeah. So Radhika, we can move on.
Yes.
Great. So this is exactly what I was referring to in the previous slide. So if I look at the big data industry today, uh, there are six broad tracks that you can look at. And as you will understand, a lot of this will be driven by the years of experience that you have uh, currently, and the kind of work that you have been doing so far. But most importantly, and as I always say this to people who are very new in this industry, a lot of this also depends on your mindset, your personality, and also what is your core competency as a professional. And I will explain this as I go along. So let's very quickly take a look at what are the different roles that we have, and then we will talk about how you can really upgrade yourselves and move into some of these roles depending on your years of experience at the moment. Yeah. So the first role that we talk about is that of a big data engineer. And big data. And I think that the normal tendency is to look at big data in terms of the size of the data. So obviously, if we look around data, and I think that the normal tendency is to look at big data in terms of the size of the data. So obviously, if we around
Hello.
tendency is to look at big data in terms of the size of the data.
Saurabh, we can't hear you right now. Hello. Hello.
Hello.
Hello.
Yeah, Radhika, can you hear me now?
Yes, Saurabh. Can you? Yes, I think we can hear you now.
Yeah. So I lost the connectivity for a while.
No
Yeah.
worries. So what I'll do is I'll just go back to that presentation.
Yeah.
Just want to request everyone, if you can hear Saurabh, just let me know on the chat if you're able to hear him now, and then we can move on to the presentation.
Yeah.
Okay, great. Manjesh has replied. Everybody else, can you hear Saurabh? Should we move on to the presentation again? Okay, Saurabh. So yes, we're going to just move on to the presentation again.
Okay. Okay. Yeah. Really sorry about that. I lost connectivity.
No problem. No problem.
Okay.
Okay, great.
Cool.
Everybody can hear. Now we're back. Saurabh started talking to us about the broad tax in big data that professionals can pursue depending on what their skill set is. So again,
Right.
Saurabh, we're going to go back to that.
Right. So I was talking about the engineer track. When I unfortunately lost connectivity. So what I was saying is that for each of these tracks, what we would do is we would look at whatever skills you may already have, and then what is the additional or the incremental skill that you need to acquire to be productive in that particular role. So if we look at big data engineering, so if you are a Java practitioner, or if you are already doing .NET programming, then you already have a lot of object oriented programming concepts and skills, and that definitely helps you for this role. Or a lot of us are basically data professionals, right? So you may be working on different relational database management systems or data warehouses already, so you have a fairly good understanding of data structures, data modeling, what are the different algorithms we use. So these are some of the enabling skills for this particular role. And what you now need to do is go ahead and acquire knowledge on some of these big data frameworks like Hadoop, and Spark has become extremely popular very recently. And then there are languages like Python and Scala, which are very relevant for big data programming. The second track that we are looking at is that of a business analyst or a business or a data analyst, and this is essentially the person who's basically performing a variety of roles, like he's understanding some of the business requirements that the client wants us to work on. So the example that I gave you, the client will essentially come to you with a business statement. He will only say that I would want to understand what are the parameters which are affecting my sales and how can I improve sales. So this is a business statement, and how you actually translate that into a technology requirement and develop a technology solution for him is what the business analyst is supposed to do. And then again, you have the role of a data analyst. So once you have collected all of the data, the examples that I gave you, like the weather data, the income data of the people living in the neighborhood, the events data for the different events which are happening in the neighborhood, and of course all of the sales data, the customer information. How do you make sense out of the data? So that's what the role of a data analyst is all about. So basically you need to have uh, I think from a technology perspective, you need to be able to run SQL queries, which a lot of us are already doing in all of the database projects that we do. And then you sort of take it ahead by acquiring your skill in various platforms. So there is the Pig, there is the Hive, there is Spark SQL. So you need to understand some of these technologies, and also once you have analyzed the data, how do you present the outcomes? Okay, so this is where you have the visualization tools like ClickView and Tableau, and so on and so forth. um, then we come back to a lot of infrastructure aligned roles, like let's say the infrastructure administrator or a data administrator, right? And a lot of us are already doing these roles. So we have Unix administrators who are basically managing large Unix platforms, operating system level. Then we are also managing a lot of these different products that are installed on such platforms. So great opportunity for all of these infrastructure and data administrators to move up to the next level, so that you have an understanding of how the big data infrastructure looks like. So what is distributed computing, how do you set up the different Hadoop clusters? So great opportunity there to really upgrade yourself. uh, then for some of the more senior profiles, uh, a lot of us are playing architect roles. And while we are playing these roles, we obviously have an understanding of a holistic understanding of enterprise architecture, about how different systems talk to each other, about integration technologies. We're already doing that. It is just that we need to put all of these in the context of a big data architect, where there are some new architectures which are being used today, which is the lambda architecture, there is the cap theorem. So these are some of the new skills that you need to acquire to become a big data architect. uh, and then of course, uh, there is a huge population of people today, especially in the the 10 plus years level, who are working as project managers and delivery managers. And the question I often get is, how does this level of people actually move into the big data careers? Now, what you need to understand is that all of these programs will still need project management and program management skills. However, I think the big differentiator today is that these roles are not, operational roles. So this is something that we need to be very clear about in today's market. Uh, and for a big data manager, an organization is not looking at that person purely as something who would be doing operational work, like resource management, utilization management, revenue management. These will of course be there, because these are essential parts for an essential activities for any organization to perform. But then again, these persons will have to be extremely conversant with big data technologies. And I'll tell you the reason why. Because, first of all, a lot of these project management methodologies are different. Okay. So none of these big data projects that we do today is executed in a standard waterfall model that we have been using traditionally. A lot of these big data projects have to be delivered using the agile methodology, and and I tell you the reason for that. See, all of these technologies are very new, right? And they are still these technologies are developing, they are evolving as we go along. So our clients are also not very confident and sure about the value that they can derive from a lot of these projects and the programs. So one of the first and foremost things that we need to be careful about is that we demonstrate tangible and measurable value to the client very frequently. So we will no longer have a situation where we sign up for, let's say, a 2 year project, and the business value is visible to the customer after, let's say, 1 year and then 2 years. It's not going to work like that. So like every 1 or 2 quarters, you have to start generating tangible deliverables, and these deliverables should immediately start driving business value for the client, for him to be convinced about the value proposition of the work that you are doing, for these projects to continue, and so on. So the key thing is that this has to be done in an agile manner. So you have to be very confident and comfortable in delivering projects in the agile methodology. Similarly, another important aspect is how you do knowledge management, because what's happening is these are all extremely new skills, and you can no longer go back to the traditional mechanism where you have some knowledge portals in the company, standardized, benchmarked, and every time there is a project on that technology, people go to the portal, get trained, and come back. These are very new technologies. You would probably not have a lot of material available internal to the organization in order to train and skill your people. So you have to be very intelligently devising mechanisms by which you can skill and enable your teams. So knowledge management plays an extremely important role in the overall job of a project manager, in the big data scenario. So just some examples of the new uh, requirements from the project management role. And then the best, or I would say the most prestigious role, from a also from a compensation perspective in the market today, is that of a data scientist. So, and it's a very interesting question as to what exactly is a data scientist, because we the term is used very loosely in a lot of communications that go around today. So a data scientist is a person who, on the one hand, has a variety of technology skills. So he has an understanding of big data engineering. He knows analytics. He's able to make sense out of the data that the big data engineers are putting together for him. And at the same time, this person has to have a good understanding of the business domain. So if I am a data scientist working for a retail company, I need to understand the retail business very well. If I'm working for a bank, I need to understand the banking domain very well. So the domain knowledge is important. Then he has to have an understanding of mathematics, statistics, a lot of these different statistical models that he has to come up with, because at the end of the day, his job is to make sense of the data, and make predictions based on the data that he is working on. So a lot of these foundational skills in mathematics and statistics and economics will definitely come in handy. So data scientist, just so that you are clear, is basically an overarching umbrella of all of these skills taken together, and big data engineering is an extremely important component of that. If you do not understand big data, if you do not understand big data modeling and how the whole big data ecosystem works, then a crucial component of knowledge for a data scientist is actually missing. So again, extremely important for data scientists. So I wanted to give you a view of the different roles that we have, uh, and how, what are the skills that you need to get into those roles. But as you must have understood from what I've been telling you so far, it is very important to understand who you are as a person. Where are your core competencies? If you have a very analytical frame of mind, you are able to play around with data, you are able to make sense out of data, then you would probably be attracted towards a lot of these roles around, let's say, the data analyst, the data scientist, and so on. If you are uh, if you have the mindset of an architecture, who's very comfortable in understanding very large enterprise systems, how these systems integrate, how data flows across the organization, and you are able to really visualize all of that, then you are a very good candidate for the architect kind of profiles, right? And if you are more of a management person, who's been managing very large programs so far, then you obviously have a career in big data project management and delivery, but obviously with some of the additional skills that you will have to acquire in order to be productive in that role. So it's also very important to figure out who you are as an individual, and just not get into a role simply because of let's say the salary or other considerations. You really have to be productive in that role, figure out what you do best as a practitioner before you go there. Yeah. And I'll be happy to take questions on that as we go along. So the
Great.
next slide,
So
Radhika.
thank you.
Yeah.
Thank you so much, Saurabh. So at this point, actually, we have a very interactive and lively group who are listening to you right now. So they
Okay.
have a whole bunch of questions about what their background is and how they can enter the big data field. So
Yeah.
given that you have just touched upon the six broad tracks, before
Yeah.
we go on to how they can upskill, do you think we
Hmm.
can take some of the questions right now?
Yeah, sure, sure. This will be relevant. Yeah.
Great. So we have Dinesh Verma. So Dinesh Verma has 1.5 years of experience. He works in IBM as a distributed batch operator.
Okay.
So what Dinesh's two questions are. First is that for a big data job, will companies accept me as a fresher or do they expect relevant experience?
Right. So great question. I think, see, the first thing that we all need to be aware of is these are very new technologies. So if you really look at the market today, the average years of experience in the big data market today is only 3.5 years. And all of these technologies actually started becoming or let me put it the other way around. Our clients started uh, you know accepting these technologies for very large enterprise programs only a few years back, maybe like less than 5 years back, that clients actually started executing very large scale big data programs. That has happened over the last like 2 to 3 years maybe. uh, so the first thing that you need to understand is that we really do not have a lot of veterans in the market today. All of us are basically learning this very new. The question is, how quickly are we learning this? So the definition of fresher from a big data perspective is slightly different as compared to the how we define freshers for other technologies. Now, the second part of my answer is this, that whether it's a big data role in your current company like IBM, or whether you are looking for a big data role in the market in general outside your current organization, every company will look for one thing, and they will try to see if you have applied the knowledge that you have acquired in a live scenario. And I do not use the word live project because you may not have the opportunity to work in a live customer project on big data. But the thing is whether you have applied this in a live scenario. And by that, what I mean is this: see, as these technologies become popular, and you saw the incentives, right? So a 30 to 60% hike in salary across the different groups. Uh, there is a tendency among a lot of us to do. Let's to go through a few YouTube videos on that, to do some of the self-paced learning programs on Coursera, or some of the MIT education portals and all of that, which is excellent, and I definitely encourage that. If you go ahead and learn, but the problem when you start using this knowledge to find a job is this: that you have not applied this knowledge to an industry scenario. You need to work on a case study or multiple case studies which are uh, aligned with actual industry requirements, and that is something an organization would look for, because there are a lot of people who are getting self-trained and who are doing a lot of these learnings by themselves, which is a great, and which you should continue to do. But today, if I am to put you on a live project and I expect you to be productive from day zero, I would expect that you have been in a live scenario where you have looked at a business problem and you have been able to apply your knowledge to solve that particular business problem. I think that is the key piece that is missing when you are going for a lot of these self-paced learning initiatives. So that is what companies would look for. So today, uh, even within organizations, if we want to enable people, the first step of course is a training. They have to understand the technologies, they have to acquire the right skills, and then they would probably have to shadow some projects, or they have to execute some real life case studies uh, derived from projects where you apply that knowledge. And that's the point when you can really become productive as a big data engineer, and the companies can actually start positioning you in front of their clients to get into the projects. The number of years really do not make a lot of difference here, in my opinion. It's basically about how well you have learned these technologies, and have you been able to apply these skills to very realistic industry problems. So that's the answer to your question.
Great. Thank you so much, Saurabh. Ankit, I hope that answers your question. Please feel free to write any follow-up question that you have. So very interestingly enough, Saurabh, we have two people over here who are listening to you right now, Ankit and Runal, who are both working as assistant professors in engineering colleges.
Okay.
So Mrinal has 14 years of experience, and we have Ankit who has around 4.5 years of experience
Yeah.
as teaching as an assistant professor. So they both actually want to know whether they should be looking for a career in the big data field, and if they should, then do you recommend them to go, and what should they do about it?
Right. No, absolutely. I think, see, the key thing about big data technology is this whole uh, collaboration with academia. In fact, I personally sit on the advisory board of a couple of very large universities, and it's very exciting to see that there is a strong collaboration between these two different groups, the industry and the academia. And the reason for that is this: that the foundational platforms for big data Uh, are basically coming out of research, right? And a lot of these is basically driven at an academic level. So all of these concepts around distributed computing, around massively parallel processing, all of these are essentially the outcome of an extensive academic research that we are looking at. And it is not just about the big data platforms or how you set up those platforms and how you handle data at scale, how you handle data growing exponentially, how you handle parallel processing, but it is also about how you analyze the data. And that is where what we see today is that a very large population of statisticians who earlier would only look at academic careers, or some of the careers in accounting or in the financial services companies, are now basically coming into the data and analytics space, because there is a lot of academic knowledge that you can apply in this area. So the answer to your question is definitely yes. There's I mean, I do not know what your areas of specialization are, but irrespective of whether you come from a computer science kind of a background where you are dealing with a lot of these uh, data structures, or different kinds of clustering data, or parallel processing, or distributed computing, or grid computing, or even if you are coming from, let's say, a statistical background where you have deep knowledge in, let's say, time series data, how you do correlations and all of that. These are extremely relevant for this field, so you can definitely come in. And I would refer back to a comment which I made when I was going through the slide. It's very important to look at your own personality type, what is your area of expertise, and figure out like which of these roles you are very comfortable to get into. In fact, with a lot of academic background, people also do very well in some of the the business slash data analyst kind of a profile, because you have a solid understanding of the underlying technology. So when you listen to somebody saying that this is the problem I'm trying to solve, you are often able to recommend what is the best technology architecture for being able to do that. Or if you have a more statistical analytical bend of mind, you could be very suitable for a data analyst kind of a role, where once the big data platform is set up, once the data is aggregated and correlated there, you basically do a lot of statistical modeling, do a lot of predictive analytics. You are able to do that. So yes, definitely opportunities exist for people from academia.
Great. Thank you, Saurabh. So we also have Manjesh. Manjesh is working with Mindtree Limited as a business analyst, and he
Yep.
has 12 years of experience.
Yep.
So his question is, what is the difference between the big data engineering and data scientist track differences?
Okay. I briefly mentioned this when I was
Yes.
taking you through the roles. So the data science is essentially an aggregation of multiple skills. So the data scientist would, as I said, there are multiple things that a data scientist is expected to do. So the data scientist, first of all, has to have a deep understanding of big data engineering. So he needs to understand, various aspects of how data is being ingested or how the data is being curated. He has to have an understanding of how the data is being consumed. So there are three C's, right? So you basically how you um, you know uh, acquire the data, how you curate the data, and how you essentially consume the data. So that is an important aspect for the data scientist to understand. Secondly, the data scientist also needs to have a thorough understanding of analytics. And when I say analytics, as you are aware, uh, there is a significant change in the way uh, analytics is shaping up, right? So it is no longer about very standardized ad hoc, standardized canned reports that customers used to work on earlier. So today it is more about ad hoc reporting. It is a lot about real time reporting. It is about reporting which is driven by the immediate needs of the business. So you need to provide a certain kind of a platform to customers where they are able to go into a dashboard and they are able to generate reports across various dimensions around what you are essentially looking at. So all of these aspects are very important uh, for a data scientist. Now, sorry about that. Yeah, for a data scientist, so essentially it's an aggregation of multiple areas like big data engineering, analytics, data visualization, which would comprise the responsibilities of a data scientist. And of course, I mean, you know this as a business analyst. The other very important thing is how you listen to the business problems of a customer and how you put that in a technology context as a data scientist.
Great. Great. Thank you so much, Saurabh. We now have Chaitanya. He is a corporate strategy manager
Uh-huh.
and he wants to understand the applications of big data in the field of finance.
Great. So I think great question, because if I really look at the industries who are embracing big data today, some of the biggest applications are in the area of finance, and I'll give you a couple of examples. So one is if you look at some of the investment strategies that a lot of these finance companies work on, a very important source of the data is basically the market data, and big data engineering allows you to work with a platform. It basically provides you a platform where you are able to capture and process very large volumes of market data in real time, and you can actually make a lot of dynamic and realistic and authentic investment strategies based on all of this market data which you are capturing in real time in very large volumes. That is number one. Another very important use case of big data is basically in the area of managing frauds, and I'll tell you how and how big data is essentially enabling that. So what happens is, today, if you look at a company like, let's say, American Express, right, which has like billions of card users across the world, and you have the customer profile stored in one of, let's say, their traditional systems. So you could have a customer management system, you could have one of your data warehouses where a lot of this customer information is stored today. Now, as all of these credit card transactions are happening across the globe, first of all in very large volumes, and secondly in real time, so that there is also the aspect of velocity, which essentially means that you are dealing with very big data. uh, from a fraud management perspective, there is a need to monitor and control all of these transactions in real time, and this is a classic real time big data use case, right? And that's the reason why there are technologies today like Spark Streaming, which basically deals with very large volumes of data in real time, so that at the point of transaction you are able to uniquely identify if this is the right customer, if this is a valid transaction, and so on. And you basically need to do that by correlating the transaction data in real time with the customer profile, which is basically stored within the enterprise. And by doing a lot of these at very fast speed in real time, it's actually adding a lot of value. So this is the second important use case that I wanted to talk about. So these are some of the areas where we are seeing considerable applications of big data. And over and above that, there is always the very important use case of increasing your customer base. And that is where financial companies are basically coming back to big data technologies in areas like prospect management, customer onboarding, and also a lot of the marketing and campaign management activities. Because what happens is, today, if you have see, typically what's happening today, you have the customer profile which is stored in the financial services organization purely based on whatever data you have captured about the customer. But there is a lot of customer intelligence you can also capture from outside the enterprise. So in terms of what is the network that the customer belongs to, which you can figure out, let's say, from his social media data. And based on whether this customer is an influencer within that network, that is all of his friends and affiliates would basically look up to him as an influencer. You can position your product and service to this particular customer to talk about your product to some of his within the network. Also, a very important application from a social media perspective, and I just wanted to briefly touch upon that. And remember, even to others in the call, this is not just about FS, but the social media perspective is important for multiple domains. Is that by looking at the tweets of a customer, by studying the profile of a customer in social media, you can also have a very good understanding about the intent of the customer. So I may put on a tweet saying, I really want to purchase iPhone 10, and this is very good information for, let's say, a dealer who's actually selling that product, who can immediately position an attractive discount or an offer in front of me, and I will really go for that. Social media is also a very good indicator about the stage in the life cycle that the customer is in. So let's say there is there's a fresh graduate who is coming out from college. So for a financial services company, it will be very lucrative to position a credit card in front of him. Maybe he's got his first job, he's getting his credit card, so you put an attractive proposition in front of him. Or somebody who's probably getting married, or somebody who's had a child, or somebody who's actually, let's say, traveling to a different country. It is very useful to have all of this information at your disposal, and you can project, let's say, an insurance scheme in front of that person. Or let's say, or somebody who's going abroad, you are offering him a forex card, and so on and so forth. So multiple applications of big data in FS. And as I mentioned, some of these are very relevant even to other industry domains. So and we are working with a lot of FS companies on these use cases.
Great. Thank you so much, Saurabh. So the next question that we have is from Amit Joshi.
Mhm.
Amit has a total of 6 years of experience.
Yeah.
He does project management in localization,
Okay.
dealing in translation.
Yeah.
So Amit's question is that how can big data help in the translation and localization industry?
Right. So I think some of these use cases that we obviously talked about. So what we need to understand is that uh, it's basically the other way around. So as we look at a lot of these big data applications, there is a uh, all, at the end of the day, where is the data coming from? So a lot of the social media data that we talked about, for example, it is being generated by customers themselves. And today what I'm seeing is that for a lot of global organizations who have businesses in, let's say, European markets, a lot of this data is not English. Again, businesses which have operations in, let's say, some of the Asian markets, a lot of data is in the corresponding local languages. Now at the end of the day, uh, if you really look at the overall objective of a big data program, it's essentially to correlate customer data with not only among the different customer segments that exist globally, but also with the information that an organization is storing within some of their legacy systems, some of their internal applications, how you actually correlate that. So there is a tremendous opportunity of translation services, language localization services, and all of that. And the other important aspect is also that what happens on the downstream side. So once you have aggregated the data, correlated the data, which could be in different languages, by coming to a standard, coming to some level of standardization, you also have to analyze and make sense out of the data and present the data to customers in a form which makes meaning to them. So even on the consumption side, if I look at some of the data services or some of the data visualization services, there are opportunities for localization work, because at the end of the day, you are creating a visualization dashboard, maybe for a company executive who's sitting in Japan, and you have to present the data in a certain language for him. So yes, so even on from that perspective, there is a lot of opportunity. But of course, you have to understand and learn what are the underlying technologies by which you can actually expand your current experience in translation and localization work.
Great. Thank you so much, Saurabh. We have Abhishek Mishra with us. He's a Cassandra admin.
Yeah.
He wants to understand that are there any opportunities for Cassandra implementation of big data, or is the market just filled with Hadoop? So because
Okay.
of
No.
this, he
Yeah.
wants to know, does he need to learn Hadoop?
Okay. No. Great question. So I think so. First of all, let's have a very clear understanding that this market has huge potential for Cassandra. I mean, that is something that all of us has to understand. I think a lot of these NoSQL databases are extremely important today, and I will give you a classic example of how these two can coexist. So you remember the the project that I talked about this whole retail chain having their outlets in different parts of the city, and we wanted to compare sales and predict sales. So there was a data lake. So I did not go into technical details because I was not sure about the composition of the audience. But since you are already working on Cassandra specifically for you, you would understand where I'm coming from. So essentially, what we did was we aggregated the data on a Hadoop platform, a Hadoop data lake, and we used Cloudera for that. Just so that you know. But then again, on top of that, we actually had a layer of NoSQL in the form of Cassandra and Redis, and we actually used that so that we could run our queries better. And Redis, as you may be aware, actually provides very optimized caching and performance management, performance optimization. So I just wanted to give you an example of how these two can coexist in the same architecture. So the answer is yes, definitely. What you are doing right now has a significant value add. However, what I would also like to say is that it would be very helpful if you can also understand big data engineering from a Hadoop perspective, because there will be a lot of applications where these two will coexist. And if you are working even on the Cassandra layer or the NoSQL layer, it would be very helpful if you understand the underlying big data platform, which is the source of data for the NoSQL part of the solution. So it will essentially give you a more holistic a view and make you more relevant for some of these projects. Yeah.
Great. Thank you so much, Saurabh. So we have 3-4 more questions, but they are more related to how this course can help them progress in their career. So
Yeah.
what I will do is, if you're okay with it, I'll just very quickly give a 2-minute introduction to the course.
Yeah.
And then all of those questions, I will pose it to you so that you can answer it better for our viewers.
Sure.
Great. So as you all know, the program we are talking about right now, it's the BITS Pilani postgraduate program in Big Data Engineering in association with Upgrad. So a very quick introduction to the program. This program is going to be launched. The second cohort will be launched in March 2018. All of you must have already submitted the application form. If you have to take the test, we urge you to take the admission test immediately if you have received a notification for that. If you have already been shortlisted for the program and received your offer letter, big congratulations for that. As you all know, the program duration is 11 months. It's an online program along with offline connects and base camps. I will be explaining that to you. The amount of commitment required is 8 to 10 hours commitment per week. We have a lot of flexible payment options, including 0% EMI. So the course is priced at rupees 2,25,000 rupees. You can take advantage of our loan or 0% EMI. Very quick key features about this program. You get a postgraduate certificate by BITS Pilani along with lifetime alumni status from BITS Pilani. A key factor of this program is that you do 150 hours of hands-on projects on AWS cloud. as Saurabh has been mentioning this entire time, is the important aspect is that you should be able to apply big data to business scenarios. And that is exactly what we help you do through 5 projects from the industry that you will be working on, including with experts from Savan, Edelweiss, etc. Like mentioned, this is by the industry and for the industry, because the important thing is that you should be upskilled enough for the industry to be able to hire you after this program. You will be meeting a strong peer network. As you can already see from the chat, the kind of people who do apply and get in are people with extreme interest in big data or some prior relevant experience. So a fantastic network of 200 to 300 people that you have access to. For all of the assignments that you do, you will receive personalized feedback and grades to know exactly where you can improve yourself going forward. We have extensive career support services, and since some of the questions pointed towards that, I will just spend some extra time on this. We provide career support services for each step of the way. So, from step one, where is that you get to have a consultative call with an industry mentor. So, like you're seeing, all of you are being able to ask Saurabh questions very specific to your career, just so that you can understand that given your background, what is the best way for you to go forward. That is a one-on-one opportunity that you get once you enroll for this course. You will be able to speak to industry mentors like Saurabh so that you can understand what you should be doing next. That is just step one. Step two is for you to be able to build your resume and your LinkedIn profile. Now, that is the first criteria on the basis of which you will be shortlisted for any job. And we will review your LinkedIn profile and your resume to give you great feedback on how you can position yourself better. Step three is, of course, job interviews and access to opportunities. Upgrad has a network of 100 plus companies where we will be collecting job descriptions from these companies and sharing it with you, and in turn, sharing your CVs for the interested positions with the companies. We will schedule interviews and handle logistics where applicable. The fourth point, of course, is that you cannot go for an interview if you are not prepared. So we help you with mock interviews and mock examinations with industry experts so that you will put your best foot forward when you do apply for a job or when you do sit for an interview. Like I said, end-to-end support to make sure that you can make full use of this opportunity and kickstart your career in big data. As I mentioned, we also have individual student mentors who will be pushing you and egging you throughout the course of the program to support you in any sort of help that you require. We also have teaching assistants and a 24/7 discussion forum where you can answer any doubts that you have at all about the program. Lastly, this is an extremely flexible program where you have on-the-go learning either on mobile or laptop. So it's very, very flexible for you to do whatever, to learn at whatever is convenient for you. So that is a very quick introduction about the program. Now I'm going to be taking some of the questions related to the program that you all have posed. So Saurabh, we have a question by Sarathi. He has 7 years of experience in engineering, out of which 2 years he spent as a software developer. Now he wants to understand if this course in big data will help him set a career path in the big data field. Saurabh, can you hear me? Saurabh, can you hear us?
Yes, I can hear you. Sorry
Okay,
about that.
no
Yeah,
worries, no worries. So, Saurabh, we now have Sarathi, like I mentioned. He
yeah.
has 7 years of experience in engineering, out of which 2 years he spent as a software developer. He wants to understand if this course in big data will help him set a career path in the field of big data.
Yeah, absolutely. So I think I do not know which particular platform you've been working on as a developer, but one of the things that you need to understand is that, see, all of these courses that we do, right, as Radhika was explaining, this obviously has some prerequisites. And in fact, when I was taking you through some of the different roles or the tracks that we have here, as I mentioned, that all of these roles will have some of these foundational or enabling prerequisites which as a programmer you would have in in one of the different options that are there. So if you have been doing, let's say, programming in an object oriented language, and you are proficient in, let's say, Java J2EE, or on the .NET platform, that's an excellent prerequisite to go with, because you already have an understanding of object oriented programming principles, which are extremely important for this. The other the kind of programmers that I see are basically on the database side. So probably you are, I mean, you may be a relational database management system practitioner, or who've been working on some of these projects. So maybe you are comfortable in things like SQL, or writing procedures and so on. So even that helps, because at the end of the day, you need to have a good understanding about data modeling, data structures. Having said that, what I would also say is that you need to be a flexible learner, the way I put it, because as you start going through the course, as you go through some of the foundational modules of this whole program, as you would realize is that a lot of these RDBMS concepts that we have been traditionally working on are not valid here. So I think somebody in the audience mentioned that he's a Cassandra professional. A completely different paradigm if you really compare it with some of the structured RDBMS data models that we look at. However, it always helps to have an alignment with data principles. So the key message is this, that irrespective of what kind of foundational skill you have, whether it's on the programming side or on the database management side, these are definitely advantages, there are definitely benefits, and this will only help you pick up some of these technologies and principles very fast, and you can become productive from a big data perspective.
Great. Thank you, Saurabh. So Sarathi has mentioned that he works on Python and Sita, and he's trained in Java as well.
Excellent. So in fact,
So that
if yeah, that's a big plus, because I think Python again is the language of choice for a lot of these big data applications today. So Python, Scala, and Java. So these are definitely languages of choice. So I would say you are already in the journey.
great, great. Thank you. So yes, Sarathi, as you heard, you're already trained in Java as well. So that will not be a problem at all, because the course is also primarily teaching you in Java. Great.
Yeah.
So the next question that we have, Saurabh, is from Shravanti.
Mhm.
So Shravanti has 10 years of experience with development and testing background. A
Yeah.
bit more details is that development experience that Shravanti has is in mainframes and automation testing experience in
Mhm.
Selenium and .NET framework.
Mhm. Yeah.
So Shravanti's question is,
So yeah.
once I start this course, how quickly will I be able to apply this knowledge in real-time big data projects in my own company?
Okay, no, great question. So I will answer this in two parts, and the first is about how you, as an individual, can really, acquire the required skills and then become relevant. So based on your experience, since you have an exposure to, as I was answering to the other question, if you have an exposure to the Java platform, to the .NET platform, as you mentioned, I think you already have some of the enabling skills to get started with the big data engineering piece. And now, as you must have also seen, a lot of these testing operations are getting automated, right? So there's a huge focus on test automation, and manual testing. In my view, after the next few years, manual testing would be would be conducted by a very small percentage of practitioners. It's mostly about automated testing and how we are able to embrace some of those technologies. So that's the right way to go. Absolutely no issues on that front. In terms of how quickly you would be deployed within your current organization in a big data program, I would not want to make a very generalized comment, because what I've seen is that the policies will differ from company to company. But typically, having seen this in a couple of large organizations that I've been associated with, typically what happens is, see, what you must understand is every company is also, just as you are very keen on learning new technologies and making yourself relevant, the companies are also struggling to find all of these practitioners, because these are not commodity skills which are available in very large numbers in the market. So these are skills which are very rare. They are not too many people in the market who have these kinds of knowledge today. So the sooner we acquire these skills, the better are our chances for deployment. Having said that, and as I have been stressing on all along, the key thing is you have to demonstrate to your company that not only do you have these skills, but you have also applied these skills in some of these practical industry scenarios. And that's where if you are able to work on some of these industry relevant case studies, that will definitely come in handy. And I think ideally there shouldn't be much of an issue to find another avenue within your current organization, in the test automation side, or some of the big data testing projects. That should not be a problem.
Great. Thank you so much, Saurabh. We hope that answers your question, Shravanti. So, Saurabh, we have the last three questions for today's session, given the
Okay.
lack in time that we have.
Yeah.
So, we have Ankit who's asking, what are the tools used in the big data for infrastructure and data admin role? And does this program cover those tools or not?
Okay. So, see, the key, in terms of tools, what I would say is that whether the big data, if you look at some of the standard big data platforms today, so whether it's Big Insights, or let's say the Hadoop or Cloudera, so they have their own deployment suites, and it's really very intuitive, and you can set up some of these clusters very fast. And so that's the first part. And in terms of the second part, I think, and Radhika, please confirm my understanding. I'm sure there are opportunities for you to actually, set up and configure some of these environments on AWS cloud, so that as part of the big data engineering piece, you definitely get to do some hands-on in terms of setting up these tools, configuring the environments, and so on the cloud platform.
Yes, yes, that's true.
Yeah.
Great. So the second last question that we have, Saurabh, is from Runal. He talks about how is this big data course different from other courses? And his second part is how will they help in placement? And Runal, I've already answered that for you. But Saurabh, from an industry perspective, from an independent industry perspective, given that you know about the key features of our program and what sort of skills we teach, what
Yeah.
do you think is the one differentiating, or what are the main differentiating factors of this program over other programs out there?
Great. So I think, if you ask me, I would typically rate a program on primarily three parameters. One is whether you are able to play around with the different technologies, whether you are able to get your hands dirty with the different technologies, and whether you have access to uh, the right environment, the right infrastructure, and the latest versions of the different products. I think a lot of that gets lost when you are doing online programs, or you are going through self learning process. A lot of that goes missing. So I think being able to really touch and feel all of these different technologies, having a feel of the cloud environment, how you actually work on that, is extremely important. Because even in the real life scenario, a lot of these projects are like that you would have, let's say, cloud data warehouses, and you would be working on Hadoop clusters which are set up on the cloud platform. So very important to have a feel of how these things really work. You should be able to really be productive from day zero on some of these platforms, some of these technologies. So that is very important. The second thing for me is, as I have been mentioning, whether you have an opportunity to work on case studies. And I know, and Radhika also mentioned it when she was presenting her slide, that there are case studies from Savan, which is a music streaming service provider. You have an Edelweiss case study. So I think these are extremely relevant industry case studies. So if you have an opportunity to work on those case studies, I'm sure that that's a huge differentiator as compared to other programs. And the third key thing, and again, this is something I touched upon when I was responding to the gentleman who are working as professors, is this important collaboration between the learning process and the industry. Because in many cases, that doesn't happen. So you do not have a feel of what kind of projects are happening today. So the conversation that we had some time back, where I talk to you about some of these use cases from the financial services organization. So it's very extreme. So it's extremely important to have an understanding of that. So tomorrow, when you are put on a, let's say, a program where you are interacting with, in a project in your company where you are interacting with a client from a bank or a financial services company, you are confident. You can rewind to the discussion that we had today, and you can say, okay, Saurav talked about these 5 case studies for the financial services company, and you can actually talk about those, which I think is very important for somebody who's coming out of an educational program, also being able to relate that to industry case studies in your conversations, in your interactions with your colleagues and clients. I think that is extremely important. So the third criteria I would look at is, does this program allow me an interface with industry? And I think, from that perspective, what Radhika presented and what I know about this program, you probably get all of these here. So yeah.
Great. Thank you so much, Saurabh. So the last question for the day is again from Manjesh. And what he wants to ask is that which track can this program help us get into of the tracks that you mentioned? So of course, we know that since this program will help us in the big data engineering track, but of course, can people from infrastructure, data admin, architect background also benefit from this program?
Right. No, great question. So I think the so Manjesh, your understanding of the landscape is very correct. So essentially, I mean, from whatever I know about the curriculum of this program, we definitely cover the big data engineering piece. The program definitely covers the infrastructure and the admin setup. It also gives you foundational concepts about the different industry applications of big data. So you are also getting ready from a business analysis perspective. You are also obviously acquiring the right skills to be a big data architect, which obviously comes with a lot of prior architecture experience, because as I always feel that an engineer sort of needs to move up the ladder to get into an architect role, because the architect role requires you to have a more holistic understanding and exposure to an enterprise, because there you are dealing with multiple systems, how they talk with each other, how the data flows across the organization from a producer to a consumer. So that's obviously a more holistic skill that comes with experience. And very importantly, what this program also does is, since you are acquiring the right skills in big data engineering and architecture, you are also getting ready for the data scientist role. This program will not right away make you ready for a data scientist role, because as I explained, that's a more overarching role, and it includes components of analysis and data visualization. So obviously you need to acquire those skills over and above big data engineering, but this at least gives you a foundation in terms of understanding big data, which is the foundation of the data science role, so to say. And of course, as I also mentioned earlier, uh, to be a data scientist, you also need to have a more analytical and a statistical bend of mind, where you are able to make sense out of data, derive insights from that. But this is definitely a step in that direction, because you are essentially understanding what new data models look like, what new data sets look like. So for the data scientist role, this is obviously a step forward. But for all of the other roles, as I explained, the curriculum pretty much covers a lot.
Great. Thank you, Saurabh. So, like you mentioned, like 5 of those tracks are completely set. You can enter into those tracks once you finish this program. And for data scientists, this is a good foundation to have good understanding of the entire big data structure and architecture so that you can go on to the next level.
Yeah, I mean, I would just make only one addition to that, Radhika. So for all of the 5 tracks, the program will give you the right skills, but then again, it will also depend on your overall years of experience and all of that. So let's say for people in this call who are like, up to 4 years or so, you would probably be looking for roles in the the big data engineer or some of the data analyst roles, whereas more senior folks would probably get into the architecture or the project management kind of roles. And obviously also on what is your core competency as a person at the end of the day. Are you more of a technology person? Are you more of an analytical person? Those factors will play, but in terms of the essential skills, yeah, the course pretty much equips you with all of that.
Great. Thank you so much. Thank you, Saurabh, for this.
Most
This has
welcome.
been an extremely insightful session, and we are very, very glad that we could have had you here today.
Sure.
So, thank you so much for taking out time. I think this was an excellent session for everyone to be able to understand from you on what are the careers in big data, why is big data relevant in today's field, and really today's in different sorts of domains today, and really be able to understand how this program will get them one step closer to kickstarting their career in big data. Thank you very much.
Absolutely.
Any last few words that you would like to tell our audience?
No, I think it was absolute pleasure. Sorry about the couple of disruptions that we had.
Not a
You know,
problem.
yeah. I mean, for all the progress that we make on data analytics, robotics, and all of that, end of the day, we still have link failures all over the world. So let's not worry about that. And all the best to all the participants. I think this is a great time for us. All of these new technologies, these are just taking off, and I'm very happy that you are taking the initiative, because a lot of practitioners across the country today, it's very easy for them to get into a state of gloom and hopelessness with all the changes that are happening in the industry. But I would really suggest that instead of reading the newspaper and thinking that okay, 70% of jobs are gone, you better go ahead and do something about it. And I'm very happy that you are taking the initiative, and my best wishes to all of you.
Thank you so much, Saurabh. That means a lot to us. And thank you so much for taking out your precious time for today's session.
Perfectly all
Thank
right,
you very
Radhika,
much.
most
We'll
welcome.
end the session here. Thank you so much, everybody. Please feel free to contact your admissions counselors for any next steps that you have, or for whatever else that you need to know about this program. Thank you for taking out time for this, attending this session today. It was a very insightful, very interactive session. We appreciate your participation and have a great rest of the week. Thank you so much, everybody.
Yeah,
Thank you,
thanks,
Saurabh.
Radhika. Bye
Thank you
bye.
so much. Thank you. Bye bye.
Bye bye. Bye.